grew plants for our project, which I suppose we could have said here, but that would be boring. So it's the long-term effects of acidic and alkaline watering solutions on the health and safety of growth of lettuce plants. A composition written by Jim W. Godkowski and Adam S. Wessler. So,
so we basically want to kind of do this in a more scientific manner. So we followed the scientific method, which was taught to us in 6th grade, and we totally didn't really forget. But anyway, that's not here nor there. So our problem was if plants are grown with different pH levels and moisture conditions, which will grow the fastest, and then we kind of had a second part to our project, which was more research based, and it was like, how is like pH levels and this information being used?
So we thought that given those conditions, the acidic and moist one would grow best because the water helps plants grow, and the acid, we just kind of thought,
because we thought that we used vinegar for our acid and then ammonia for our more alkaline soil, so we thought that vinegar was less hazardous than ammonia.
So materials, vinegar, ammonia, that's soil, pots, and water. So, anyway.
Yeah, so on March 26th, we got together and we planted the seeds, and then we just started the seeds and gave them a healthy watering of 250 milliliters of water and waited for germination. Germination took about around a week, and then we watered them with 30 milliliters of water every week, so 15 every Wednesday and Saturday. And then on 4/23, they were given their first dose of special water.
Special water. So we just watered them with water to ensure they would actually germinate and not kill them before they started growing. So for the dry-ish cells, we gave them less than the moist ones, and we debated whether it would be better to do it additively or logarithmically. So for how much water for the wet and dry, because one school of thought is doubling the amount of water and adding it, and the other is adding 5 and subtracting to each. So we ended up doing just additive because we thought it would be better. So there are compositions, they're 100%. So we look at this map, which is a representation of the alkalinity and acidity of the world's land. And as you'll notice, the world's deserts are rather alkaline. So that kind of makes it obvious that they're not really trying to improve pH if the deserts, which already don't have very much water, are alkaline. I guess that would make sense. But you see, like, Great Plains are acidic, so it's reasonable to say.
Yeah, because that's where a lot of food is grown.
Amazon's acidic, plant haven, I suppose.
Yeah. And you can see that most of, also, in contrary to the deserts in the alpine, most of the rainforest are area with more, just plants in general, are more acidic. So that kind of helped to shape our research. It's interesting, Alaska is really neutral. I just found that really interesting because it just knows that.
Alaska's acidic too.
Oh,
That's Alaska. This is Canada. So we just, that's what we just talked about. So we were wrong. It ended up being all of the plants died except for the control and the acidic with normal watering schedule. So we think that the wet ones died because they drowned. And there's a higher concentration of highly toxic chemicals. So the dry ones died because that should have been obvious. So the acidic one just ended up actually growing better. And the calculations could have been more thorough, and we could have fact-checked them. We didn't. And our schedule was a little, let's say, not regular, and the amounts were imprecise because the bets didn't work. I bought hundreds of them on Amazon, they didn't work. So, and we generalized the relative pH, which, again, we could have been more precise.
I took a lot of pictures at 3 different dates, and most of them probably aren't going to be too interesting, because most of them are going to be the dead ones, but at the end, it gets more. So it basically goes so we started watering them with we started changing their water on 4/23. So this would be 3 days after, and then it goes.
It took a month.
What?
You didn't tell me it took a month.
Oh no, I'm making this in months. Yeah, so this is 3 days after, then this is 7 days after, and then that would be 8 days after. 10 days after the first goes, and then so you can slowly see the progression.
So it's just all of them. This one dead.
Yeah.
Dead.
So you can
Alive.
You
Control.
can see depending on like how the control, how it was growing a lot better than all the other ones.
And also Tim is particularly proud of the artsiness of this picture.
Yeah, okay. You can also see how if you keep on going, you can see how you just go. Yeah. So you can see how like in the first picture it seems that like a lot has happened, but then there's kind of less progression, and until the end where the most progression has happened and it's completely dead. But it didn't. In between, there was.
The GSA meeting scheduled for this afternoon has been canceled.
Alright, let's just
Thank you.
so we have less than a minute, so let's sprint through this.
Yeah.
You just see them gradually die.
Okay, so this is on 4:30, and this is a comparison between all of the ones that were receiving the normal amount of water, and you can see that the acid is doing much better than the base, because you can see some of the roots have already started dying, and this is the last picture that we took, and this is a comparison that showing even further damage to the alkaline plant over the acidic.
And also, let it be known, if this video is shown to an earth science teacher, we want lab minutes for it.
Awesome. Okay, thank you, gentlemen.